Welcome to PodSpace. In this video, we will show how to efficiently use pipelines in order to orchestrate the building, testing and deployment of your application over many environments. Let's sign in to the PodSpace console by providing the email address and password. We have created 3 projects serving as a development, a testing and a production environment in which, during the pipeline process, the application is built, tested and deployed. It is relatively easy to set everything up from scratch, and we have a tutorial article in the PodSpace documentation site where you can find detailed instructions on how to set up the same configuration that I'm going to demonstrate in this video. In order to orchestrate the application delivery process over the building, deploying and testing stages in all 3 environments, I have set up a pipeline build, which is a basic feature of PodSpace. My pipeline definition is in the My App Dev project. Here, pipelines can be started and monitored during their progress. When creating a pipeline build in PodSpace, a Jenkins automation server gets instantly deployed and configured with the Jenkins pipeline plugin to control our pipeline. This means that we have all the power and features of Jenkins when defining what to do during each step of our pipeline. For the purposes of this video, we will use a Java-based application, which is actually one of the sample applications made for the Wildfly application server, called KitchenSync. All it does is that you can register users by entering their data on this form, and the registered user shows up on this list at the bottom of the page. Because we have different projects for the development, testing and production phase, each one may contain a different or the same version of the application. To view the pipeline definition, let's switch to the development project, open the Builds menu and click on Pipelines. Here, I can see the result of the last execution of the pipeline, and if I click on the name of the pipeline, I will be able to see the history of all of the previous executions. So let's start the pipeline now, and I will explain what is going on at each step. At this step, PodSpace builds a new version of the application in the development project. This step actually just starts a standard source-to-image build in the background. It takes the source code of the KitchenSync application from a GitHub repository, compile it, and assemble the compiled artifacts using a Wildfly-based image from the PodSpace catalog. At the end of this step, our application is packaged in a Docker image that is ready to be deployed. And that's exactly what is happening during the next step. Once the application image is created, it is immediately deployed in the same development project. Before deploying to the next environment, in the current development stage, PodSpace runs a number of basic integration tests on the application. It is done by running a Gmeter test case, which checks if the application is working properly in simple scenarios. Now that the basic tests were passed successfully, it is time to deploy the application in the test project. Basically, this step takes the Docker image that was built and tested in the development project and deploys it in the test project. At this step, PodSpace uses more advanced Gmeter-based performance tests, which simulates hundreds of users accessing the application simultaneously, each one making a couple of register operations. So, in a short time, several hundreds of users are registered. This test verifies that each registration ends successfully, and it also measures the duration that each registration took to complete. After going through the development and testing environments by taking basic and advanced tests, we can be sure that the application can be safely deployed to the production stage. In the production environment, our application is scaled to 4 instances, and the deployments are being done using the rolling upgrade strategy, which means that it stops and upgrades each instance one by one. This means that there is no downtime when deploying the application. Now that we have seen how the pipeline builds our application and it deploys it in all of our testing and production environments, let's put the pipeline to some real use and see how does it react if I introduce some errors in the application. For the first demonstration, we will introduce an error in the application by removing the register button from the front screen of the application. To do this, I'll edit the index file by changing the line of the register button. I will also change the greeting screen of the front page of the application just to make the new version more easily recognizable. Now that all the changes are made, let's restart the pipeline. Now it started building the application. The build is completed and it is deployed in the development environment. Now it started running the tests. It appears that the process failed the basics tests step. But did this change affect all the versions? let's open the application in the development environment. As we expected, the registration button has disappeared. But by going through the testing and production environments, we can conclude that the only affected version is in the development environment. Great, so we have seen that our pipeline has actually caught an error and stopped it propagating to the production environment. Now, let's make its job harder. I will introduce a different kind of error, which in turn will make the application slower. To do this, I will edit one of the controllers of the application by introducing a call to a method which introduces extra time for the execution of the application when the user registrations are processed. I will also change the welcome page of the application so we can differentiate this version. Oh, and I will also fix the register button while I'm here. By restarting the pipeline, we can see that the step at which the application fails is the performance test. Thus, the change is only visible in the testing and development environments, leaving the production one untouched. Now, let's fix the last error we have made by removing the method which slowed down the application and change the header to mark the clean version. By restarting the pipeline, we can see that the application had successfully passed all the build, deploy, and testing stages. This can be easily checked by seeing that the change occurred in the development, testing, and production environments. Even though in this example the pipeline was 100% automatic, it is not mandatory to always be like this. You can also introduce manual approval steps in the pipeline. There are literally endless possibilities. Subscribe to PodSpace now, and you can recreate what you have seen right away. You will find detailed tutorials covering this and many more features in the documentation section of the website. Don't forget, the future starts today. So subscribe now and deploy your applications in a container-based cloud-native environment.